I'd like to show you some results from Sanipath assessments from all the cities where we've conducted the assessment to date. And the figure here shows the fecal contamination levels by sample type and city. So the sample types are across the top, and then the cities are represented by the colors on the side. Each panel shows the results across different cities for a single sample type, and the y-axis shows the E. coli concentration in log scale. The arrows that I've highlighted here show results from the Sanipath deployments in South Asia, which, as Christine mentioned, there have been deployments in Dhaka, Bangladesh, and in Vellore, India. The units of concentrations on this graph are in CFU, or colony forming units, or MPN per 100 milliliters for all the different water sample types. And it's per serving for the food sample types, such as the produce or street food. For swabs of public latrines, the results are shown as per swab. And then for soil, it is shown as per gram. So on this graph, we can see that the fecal contamination levels of environmental pathways vary across the cities. First, with all of the different water type pathways, such as the open drains, flood water, ocean water, surface water, etc., we've ordered them from most to least contaminated. So the highest contamination levels were generally seen in open drain samples, and the least contamination levels were found in municipal drinking water. So raw produce and street food were often contaminated. Let me see if I can use the annotation. Doesn't look like it's showing up. But raw produce and street food, which are in the second row, were often contaminated, and sometimes we saw small proportions of food that were very highly contaminated, which is represented as outliers on this box, which these box plots, which are the black dots. And then the second to last box in this graph on the second row shows public latrine swabs, which have had low contamination levels across pretty much all the cities except in Vellore. Next slide, please. So on this slide, now we are able to see the frequency of behavior that leads to contacts with the environment for all the studied cities by both pathway, which is listed along the top, and by age group, which is listed on the side. The top row showing results for adults and the bottom row showing results for children. The y-axis shows the percentage of the population with a specific behavior frequency. So you can see lots of different colors on this chart, but despite clear variation in the contact frequencies between cities for all the pathways, what you will notice is that between adults and children within the same city, generally the contact frequencies were pretty similar. Next slide, please. So I wanted to highlight a few points on these behavior graphs. Oh, back one slide, or could you go back one slide, Bitush? Thank you. So firstly, contact with open drains and surface waters, which is highlighted here by this box, were rare in most of the cities. Next. I think maybe you need to go forward.
I think there's a lag.
No worries. Secondly, the majority
water here.
No, this is right. This is right. Secondly, the majority of the population frequently consumed municipal drinking water, is what you can see by the high number of green bars, which shows the frequency of over 10 times in within a week. However, we do notice that there's a big purple bar within these municipal drinking water box, and that is in Siem Reap, Cambodia, where all the respondents reported that they mainly relied on drinking water sources that were non-municipal, such as bottled water or well water. This is interesting because in actuality, the municipal water in Siem Reap had quite low contamination levels, and there was perhaps a mistrust in the water source quality that led to this behavior. Next slide, please. Okay, so lastly, I want to point out that the results indicate that the majority of respondents across the study cities regularly consume raw produce and street food, which I'll talk about more in a second. Next slide. Sorry, there seems to be a bit of a lag for me, but this figure shows the average monthly total exposure to fecal contamination and then the contribution of each pathway by both neighborhood, and the graph is organized by both neighborhood as well as the populations across 9 different cities. The cities in South Asia, I've again marked with the star, if you could click. The height of a bar represents the log scale total exposure from all of the different pathways, while the different colors represent the contribution from the different pathways. And here the unit of exposure is CFU or MPM per month. So on this chart, you can see from the many green and gray bars in the figure that food, including both raw produce and street food, were what we call a universally dominant pathway for exposure to fecal contamination. And this means that it is consistently showing up as contributing a large proportion of fecal contamination to the total ingestion, to the total exposure, regardless of geographic locations. And given the frequent consumption and large amount of ingestion of food-related items, once contaminated, they could easily lead to quite a large contribution to this total exposure and then easily become a dominant pathway. Next. So now we'd like to share a case study from Ghana that illustrates how the team there has been using Sanipath results. Bithush, if you click on that, it's in the PowerPoint should play, and hopefully you have the sound sharing available as well from your computer.
Sanipath is in a way is becoming a game changer. One thing that we've learned about Sanipath is that it's a tool that can complement. Sanipath is in a way is becoming a game changer. One thing that we've learned about Sanipath is that it's a tool that can complement a lot of things that are happening. Poor sanitation is compromising the quality of water supply in our country. Water safety plan, you are supposed to have environmental risk assessment. It's not just about risk assessment along the water supply chain. It should be a risk assessment of the environment, the entire environment of the community. Sanipath can fit in that aspect of environmental risk assessment of the water system, and it will offer more reliable and robust results. But there's no shortcut in responding to the issue of sanitation, that it has to be handled holistically. It's not just about throwing in a few thousand toilets for households and we think it has been solved. From the study of Sanipath, you can learn that poor sanitation have impacts not only through even compromising water quality, but it compromises street food, it compromises raw produce, it compromises the soils that even children playing. Sanipath has a spiral effect in turning things around. In Ghana, we're already beginning to think about how to even improve urban agricultural practices because of contaminations with raw produce. So I think Sanipath does not just offer a one-level information, it offers multiple information. There is not really that quick direct link between sanitation and agriculture, but through Sanipath we are able to build these linkages, and it draws attention of city authorities, it draws attention of professionals. It draws attention of governments to the need to try to improve sanitation.
Thank you. So that was a short video, and hopefully you all were able to at least hear the audio and see the video is also linked on our website at sanipath.org if you'd like to revisit it. But our colleague at the group Trend in Ghana is just sharing their experience using Sanipath. Now, this slide shows some results from the work in Kumasi and Accra, Ghana in 2018. These plots are called tree plots, and each individual rectangle represents a neighborhood within Kumasi on the left-hand side of the slide, and then in Accra on the right-hand side of the slide. And then the individual boxes have different size rectangles within them that represent the different pathways. The larger rectangles show pathways that are contributing more to that total exposure than smaller rectangles. And then the degree of the red maroon color represents the increased exposure. So what we can see from the results in Kumasi, which is from 4 neighborhoods, the top row shows adults and the bottom row results from children. For adults, both open drain water exposure and exposure through ingestion to raw produce were the dominant pathway, whereas in children, it was mostly that open drains were the dominant pathway. In Accra, which you can see on the right-hand side of the slide, for adults, the dominant pathway of exposure was produce, and then for children, it was a combination of produce and open drains. Next. So there has been some short and long-term decision and actions taken by the local authorities based on the results generated from the Sanipath deployment in Ghana. Some of the immediate actions included engaging the water utility on challenges with water quality results in slums, hygiene behavior change education in local schools, and shutdown of public toilets that were emptying directly into a local river. Some of the long-term actions, if you can click, focused on planning and policy interventions. For example, the Kumasi Metropolitan Assembly and the local NGO Trend are using money that they won through a DFID sanitation grant, partly based on the Sanipath evidence. They were able to get this grant and they developed and are implementing a food safety and quality compliance intervention. In addition, Sanipath is now a recommended planning tool by the Ministry of Sanitation and Water Resources in Ghana. And on October 7th, just this year, the government launched food safety guidelines for all the municipalities. Next. Last, I just wanted to
Surajit, can we take some questions if that is okay? I'm just there are a few questions.
Sure.
Are you closing?
Yes, this is the last slide. So
go ahead. Yeah, please go.
So based on the results that they found, the Kumasi Metropolitan Assemblies also put together a list of interventions in their 2020 annual sanitation plan. So these are interventions that will be most likely to yield a positive impact on public health. And some of the key interventions they incorporated included protocol standards to ensure food safety and quality, investment in the sanitation value chain to improve their liquid waste management, and improving hygiene in schools. So the pictures on the right show some of the interventions that KMA has implemented. For example, they began a school hygiene education and improvement of water, sanitation, and hygiene infrastructure. So these pictures show some of the completed school toilets and the hand hygiene facilities provided.